Hi, my name's Tanner, and thank you for taking the Introduction to Python Programming course. I'm really excited, so let's get right into it. Who is this class for? It's really for anyone who's interested in learning how to program, people who want to get right into the code instead of installing a bunch of stuff. We go right into it using an online compiler, so all you need is access to the internet. And ideally, it's for people who don't have any prior programming knowledge or very little, because we're going to get really basic and go over the very fundamentals of programming. So the structure of the course, we're first going to, get started, learn the compiler we're going to use, and just basics of programming, learning variables and different data types in Python. Then we're going to go into logic and loops and how we can use those in our algorithms. We're then going to go into functions, defining functions, creating our own and calling them. Then we're going to go into recursion a little bit. And then we're going to go into the basics of object-oriented programming and understanding why we actually create objects in programming and what they're really useful for. And what if you have any questions? Well, first, Google is your friend. Don't be afraid to Google anything. Chances are if you have a question, someone else has also had that question, and there's probably an answer somewhere online. Stack Overflow is great, so when you Google a question, a lot of the time Stack Overflow will be one of the first threads that pop up in your search. It's a great resource, and then you can also ask in the Q&A section of this class, and either another student or I will help and answer the question for you. So I'm excited. Let's start and get right into it. So we're going to look at what programming is, okay? Because it could be kind of confusing. You hear it a lot, but what actually is programming? So programming is simply just telling a computer that you want to do something, okay? So a computer has a different language than you do. So think of yourself when you're a programmer as a translator. So you're translating from human language to computer language and telling it exactly what you want it to do. There are many ways to do this using different computer programming languages. We're going to be focusing on Python, but there's a lot of different ones such as C++, JavaScript, Ruby, Fortran, Swift, a lot of different ones that can do a lot of different things. Python is one of my personal favorites, but remember there are a lot out there, and there's a lot of people use them to do different things. So what does a programmer do? They're the ones that implement tasks via the computer. And like I said, you're going to think of yourself as a translator. How can I translate my own human language into something a computer can understand and implement? Okay? So let's look at an example, okay? I want to be able to give the computer a list of numbers, and then I want it to return a sum of the numbers. We can do it in Python using the following. We can define our numbers as 1.2, 3.4, 5.6, 1.33. We're going to initialize our sum as 0, and then we're going to loop through those numbers, okay? So for every number, we're going to add it to the sum, and we're going to print out that sum. And in that case, if we were to add all the values and numbers, we get 11.53. All right, so just like we said, we first define our list of numbers, hold the sum, and then we could actually check if we were right. Okay, so 1.2 plus 3.4 plus 5.6 plus 1.33, and that gets 11.53. All right, so this is the end of this video, and we're going to start going into Python code. Hi, so we're going to jump right into Python. There's a lot of different tutorials on how to install Python on your computer if you wanted to play with it locally or code locally, but just to jump right into the code, we're going to use an online compiler, and that's going to be at REPL, REPL.IT. Once you go to this website, you'll scroll down, and you'll have a bunch of languages. So this is actually a great resource going forward if you want to learn JavaScript or let's say Node.js. I haven't used it for Node, but it's great on almost every single language I use it for. So let's jump right into Python. So right away, there's a few different things I want to talk about. Right here is where our files are. And if you have a text editor, locally, it'll look very similar, where you have a list of your files. This one's called main.py. This is your actual Python file and it has a .py extension, that means it's a Python file. And that's why if you wanted to work on it locally on your own computer, you would need to install Python so that it understands what to do with these .py files. Then you have this area all over here, and that's your console. That's where the output's going to go. That's where whatever you do here and you print to a console, it'll go right over here. We're going to use that a lot. So when you hear the term console, this is what you'll be referring to, and the actual script will be right here. Thank you, and the next one we will go right into coding. So let's jump right into coding. We're going to do our first program called Hello World. It's kind of the industry standard for learning how to code. Type in print, open parentheses, and a lot of the time your compiler will close the parentheses that you open. So in REPL.it it will do that. You do quotes. In Python you could use either double quotes or you can do single quotes. Type in hello world, exclamation point. So what print is a built-in Python function. When we actually cover building our own functions, it'll make a little bit more sense. But what it'll do is print anything you put in those parentheses into the console on the right over here. So if we were to click run, it's going to compile the code. And if you look on the right side, it'll say hello world. So that's how you code. You just created your first program. We're going to get obviously into a little bit more interesting programming things, but right now that's all you need to know, and you made your own first program. Let's start variables right now. A variable, broadly speaking, is simply a piece of information that the computer stores. Very basic, generally speaking. If we wanted to create a variable in Python, let's say my variable equals 1. What does this do? This tells Python I want to be able to reference the value 1 whenever I type my variable. So why not just type 1? Well, now if we wanted to change the value of my variable, we could put 2 here, and every single time we reference my variable, it'll change that value to 2. So it's very, very powerful. When we create variables in Python, we don't need to do any keywords like var or even the type of the variable, which we'll get into in the next couple lectures. And we just say the name that you want equals and the variable that you want. That's it. So let's go right into other variables. Now that we've covered the basic idea of variables, let's get into our first variable type, which is a Boolean. A Boolean is simply true or false, and it saves that value of true or false. So if I wanted to say my bool, that you may hear people say bool, equals true, then every time we reference my bool, we're going to get the value of true. If we were to say my other bool equals false, then it's going to save the value of false. True and false are keywords in Python, and you just do it with a capital T and a capital F, no quotes or anything, and it'll get the value true or false. If we were to print my type of my bool and run, we get class my bool, or class bool. It's a Boolean. So Python, when you type in those keywords true or false, is automatically going to save it as a Boolean. That's one of the cool things about Python, and we're going to learn more about that you don't need anything, you just need the variable name and the value. Okay, now let's get into ints and floats. We're going to start working with integers and floats, so let's get right into it. If we wanted to define an integer, we just write the name of the variable. We'll say variable 1 equals 1. Let's do variable 2 equals 2. And in Python, you don't need anything like semicolons at the end. You just type them out, do enter. White space matters more than anything like semicolons, and we'll see that as we go forward. So let's do print variable 1 plus variable 2. We get 3. So Python knows that you're giving it 2 numbers. When you do variable 1 plus variable 2, it's going to return the sum of them, which is 1 plus 2, 3. Pretty straightforward. Notice that Python knows that it is a type int. An integer is just any whole number. So when you just type in 1, We'll do type. Let's run it. And you get class int. So Python right away knows that you are giving it type int. Let's go into floats now. We can do 0.0 here and 0.0 here. If we were to run that, we get class float. And the reason that matters is because right when you give a decimal space to an integer, it becomes a float. Float is the number just like an integer, but it's a non-whole number. And now I know what you may be thinking, 1.0 is the same as 1. But when you put that decimal place in, Python automatically realizes that there's a decimal place, therefore it's a float. It doesn't matter if we view it as empty or if it's a 0. Python will automatically say, hey, this is a float. So if we were to do variable 1 plus variable 2, it's still going to be of class float. And if we were to just print out the answer, it'll be 3.0 instead of just 3. Where if we were to get rid of them, it's 3. So when you give it a whole number, it'll recognize it as an int, and when you give it a decimal, it'll recognize it as a float. With floats and ints, you can do any arithmetic operators. You can do addition. Let's do multiplication here. Perfect. And you could do the same thing here. 1.0. And it'll once again return a float because you're doing multiplication with floats. So that's a quick introduction into ints and floats. Nothing too crazy here. Main thing to remember is how to define a variable. You have the name variable1, which holds the value 1.0. So whenever you refer to variable 1, such as right here, it will take that number 1.0. And the same thing with variable 2. Whenever you refer to variable 2, it'll refer to 2.0. So that's basically it for ints and floats. Thank you. Now that we looked at basic variable types like integers and floats, let's look at a string. A string is simply a collection of letters. So let's say my underscore string equals hello world. Run it, we're not going to do anything, but it's going to save the value hello world in my string. If we were to do print my string, run, it recognizes, okay, my string equals hello world, so it's going to print out hello world. If we were to use type my string and run, you get class string. So just like we used type before and it gave class int, float, this is of type string. So, and the way Python recognizes it is just a collection of letters, and you define it using quotes. You can use either double quotes or single quotes in Python. They mean the same thing, and it'll still be of type string. So let's do something really simple and combine two strings. This is a very common thing that you'll use in Python. So let's use exclamation. Did I spell that right? I wasn't too good at English. Equals that, an exclamation point, and we're going to print my string plus exclamation. All right, what do you think is going to happen here? It's going to append or concatenate those two strings. So my string plus exclamation is going to concatenate the value my string plus an exclamation point, so it'll put it right next to each other, hello world. This is a very common way to combine two strings or multiple strings. If you had another one, you could just do plus again. There's a lot of different things you could do, a lot of built-in Python functions that you could look into. Strings are, very, very widely used, obviously. And notice that when we defined these two strings, one of them used single quotes, the other one used double quotes. And when you concatenate them, there's no issues because Python views those as the same way. That's it for strings, and let's go to the next video. Now that we've really gone through the basic data types in Python, we're going to go into some that are a little bit more complex and quite frankly are much more relevant in what you'll be doing for most of the time. So Let's go into tuples. And a tuple is simply a collection of data that's ordered. So it's more than one piece of data that you combine and save into one variable, which you can then reference. What does that mean? Let's figure it out. So let's do my underscore tuple equals parentheses 1, 2, 3. This is how you define a tuple with parentheses and you use commas between the two. If we were to do print my tuple, it'll print out 1, 2, 3. Let's look at type. Class tuple. Just like all the other data types, when you create a tuple, Python automatically recognizes that and saves that, so you don't need to do anything special. And now the cool thing with tuples, and what we'll learn in lists next, is that you can reference each value individually. So if we wanted the first value in my tuple, what would we type? We say my tuple, we use these braces, and then we're not going to type 1. What we want is the first value using an index. So the indexing starts at 0. This is very, very, very important. Most all languages that I can think of, unless there's some one-off language, start indexing at 0. So if we're to type in 0 here, it's going to get whatever is in the first position or position 0 in my tuple. So value of 1. Now let's try something interesting. Let's do type my tuple. What do you think is going to happen here? It's class int. So what my tuple is a data type in and of itself. It's a tuple, but it's saving 3 integer values inside of which you can then reference. So if we wanted to add whatever's in position 0, so that's 1, with, let's say, the number 2, we're going to do plus my tuple, and if we want number 2, that's going to be in position 1, and let's run it. We get 3, okay? And then if we wanted to do plus my tuple in the 2, it's going to be 1 plus 2 plus 3, which will be 6. So that's how you do, or that's how you create tuples, work with them, indexing using 0 in the very first position, then 1 in the second position. It's a little confusing, but you'll get the hang of it very quickly. Okay, so let's get into lists now. All right, now that we covered tuples, we're going to cover another piece of data that's very similar to tuples, but quite frankly is probably used a lot more or has a lot more applications. That's a list. Let's get started. So we're going to define my list equals braces 1, 2, 3, 4, 5. Now let's print my list, and it's going to print the list. Just like we do in tuples, we start referencing at 0. So in my list in the 0 index will be value 1. Okay? If we were to do type my list, we get class list. Once again, it's a built-in data type in Python. And now with lists, with a lot of data types, there's a lot of added methods that you can do. And with lists, no different. So let's start off with append, okay? Let's say we have this list of values, so 1, 2, 3, 4, 5, and we say, oh, I wanted to add the number 6 at the end. We can simply do my list.append, and then put whatever value you want to append in here. So we can do 6, say print my list, and run. Now we have the value 6 in my list. So very, very common to use that. We can also use a lot of different types of indexing, which we didn't really go into with tuples, but let's start getting into it. So if I wanted to reference number 5, okay, we could use my list in the 4, and it's going to print 5. But what if we don't know exactly what, or the length of the list? There could be a bunch of different values in there, and you don't know what index the last value is. Well, you can say -1, print, and it'll be 5. Because what this is doing is going 0 and then wrapping back around to the -1 index. So if you do -1, it'll be the last value. If you want to do the second to last value, you would do -2. Run that, and you got 4. Okay? So you could do a few different things with it. Let's say you wanted to get a section of your list. So if we were to type in :3, we get 1, 2, 3. So this means it's going to get all of the values up to the one that's in position 3. So that in position 3, we have the value 4. So it's going to get 0, 1, and 2 and return that. Okay? So our values in positions 0, 1, and 2 are 1, 2, and 3. And the reason I made the numbers different is just to kind of show you how it works. If we wanted to, we can just change this. Let's go 0, 1, 2. So it's going to get the values in index 0, 1, and 2. So all the way up to 3. Let's run it. And it's going to be 0, 1, and 2. Just because the index is also, we made the values match the index in this case. So that will help explain that. Let's say we did 1, colon. What do you think this is going to do? This will get all the values in the array, including and after everything in the first position. Okay, so it's going to be 1, or the first index equal 1. Sorry, not the first position. Index equals 1. So 1, 2, 3, 4, 5, and that's it. So those are a couple ways to do that. We can also combine those two, where if we want to do 1 to 3, what do you think is going to happen? It's going to return 1 and 2, because it'll be everything up, including and after index 1 and up to index 3. So that'll be 1 and 2. If we were to do print type of this, all it's doing is returning another list. So let's go into another very common Python data type that you'll use a lot, called a dictionary. You'll hear it referred to as a dict, D-I-C-T. It's a type of hash table or hash map. You'll hear it referred to as in other programming languages. And what it is a collection of key and values. So let's create one called myDict. You construct one using these curly braces, and you're going to put some key with a colon and then some value with a comma to separate each entry in the dict. So just like an array where you're going to put your entry separated by commas, in a dictionary, you're going to say key colon value with commas. Okay, so let's say key, and then we'll say key 2, and we're going to say value 2. Okay, so let's see how we would refer to these. You're going to print out myDict. You use, just like you would be referencing a value in a list, you use those braces and you put the name of the key. So if we run this, we will get value, okay? And that's because myDict in this key called key is going to be a value. If we were to print myDict in the key 2 and run it, it would be value 2. And we could put any value in here. If we wanted to put, motorcycle and banana, you would just say myDict in the motorcycle and run it, and you get banana, right? Because here's the key and here's the value. All right? And the cool thing about dicts is that you can mix different values. So let's say we're going to say put key 3, and we can put an int. We could also put some other key and put 4.7, right? You can put a float in there as well. So if we were to say key 3 and print it, you get 4. If we put some other key and run it, you get 4.7. If you were to say type of some other key or dict in my some other key, what do you think is going to happen? We should see float. And that's exactly what we see. We see class float. So that's an introduction to dicts. As you go through Python, you're going to be using them a lot. It's really good to understand how they work. That's it for this one. Welcome to the logic and loop section of this course, and this is what we're going to learn. Let's say we have a list of numbers and we want to determine which numbers in this list and then print them out, which numbers are divisible by 3. So when we get the remainder, so item modulo 3, it's 0, okay? So we could do that manually by checking each one, let's say, okay, so 6, 3, 9. Okay, so there's 3 numbers. We want to be able to print out 6, 3, and 9. We can go in there manually and just say print over and over. Or we can loop through and conditionally check if each one is. So this is going to loop through every item in my list, check if it's divisible by 3, and then print out the item. So if we're going to run it, we get 6, 3, and 9. Okay? Don't worry too much about what this means. It's just going to give you a little bit more context of what we'll learn in this section. Okay, let's get into it. Thank you for continuing to watch this course, and we're going to get right into if statements. If statements are really great because it allows you to do tasks conditionally if one thing is true or one thing is false. So let's get right into it. Generally speaking, your syntax is going to start with an if, and then you're going to have some sort of logic here. So let's put 5 plus 5 equals 10, colon, and then you're going to do something. So let's look at this a little bit more. It is going to evaluate whatever you put here, okay? So it's asking, is 5 plus 5 10? And notice we have 2 equals because we're not assigning a value of 10. If you saw some variable, we typically will write my var equals 10, right? And this is because we're defining the variable to hold the value of 10. In this situation, we're just checking if 5 plus 5 equals 10, and the way we do that syntactically in Python is to use 2 equals, okay? So if 5 plus 5, let's delete this, equals 10, we're going to print we are inside the if block. Let's run it and see, there you go. We are inside the if block, okay? And that's it. So the syntax, remember, is if, put some thing to evaluate in here with a colon, then you indent in the if statement, and you put whatever you want to do. And you can put as much stuff as you want. You can say print I am before the second print line. The important thing though, see, and it'll work, but it only works if they're all indented the same amount. So that's very important to keep in mind, okay? So let's get into the else part of if statements. What if this part isn't true? So let's say is not equal to 10. And the way that is exclamation point equals 10. What this does is check if whatever you're evaluating is not equal to 10. Then we're going to say we are inside the if block again. We get nothing, right? Because 5 plus 5 is equal to 10. So it's not going to even enter this block because this just said if 5 plus 5 is not equal to 10, so this is going to be false. This part right here is false. 5 plus 5 is not equal to 10. And you could say that out loud. We know that that's a false statement, so it's not going to go there. So if we go to else, we could say print we are inside the else block. Okay? And if we were to run this, we will get we are inside the else block because it's checking if this is true. Okay, this isn't true, else you're going to do this. Else blocks are not mandatory for if statements, as we just saw. You could do an if statement without an else, okay? One more thing we could do is elif or else if. You'll hear in other programming languages, there's a lot of different syntaxes for it, but it goes elif in Python, and then it's going to have some sort of logic in here. So we'll say 5 plus 5 equals 10. Then we're going to say print we are inside the elif block, okay? And the elif block is the exact same thing as the if statement, but it's just elif, and then you put whatever you want to evaluate. Now the else is going to happen regardless, so you don't put anything in here for the else statement. You don't need it. It's not evaluating anything. It's just defaulting to that if everything else above here is false. So what do you think is going to happen in this? Just try to think about it, and let's run it. It's going to say we're in the elif block, right? Because it first goes, okay, is 5 plus 5 not equal to 10? No, this part's false. This statement's false. Elif 5 plus 5 equals to 10. Oh, that is true. So now we're going to execute this, and then we don't even hit the else because it's already evaluated this if block. Okay? So if we're going to do one more thing and say 5 plus 5 equals 9. So if 5 plus 5 is not equal to 10, we are inside the if block. Elif 5 plus 5 equals to 9, well, that's not true. So it's going to skip this, and it's going to keep on going. So if we were to run, we should get, we are inside the else block, right? Because this, false, false. So by default, it goes to the else. If we were to get rid of this, what do you think is going to happen? Nothing, because neither of these are true. Okay, so it's just not going to do anything because it can't go inside of those blocks. All right, so that's it for if statements. This is, much more technical than the other ones we've gone through. It's good to practice with a lot of different scenarios. So that's what I would suggest. And, there's obviously a lot more we can do with determining these. Right here, we could do greater than or equal. We could do less than or equal. We could just do less than. So feel free to play around with a lot of different things. Okay. Now that we've learned if statements, we're going to look at a practical application of it. It's a common coding exercise called FizzBuzz. So the general idea is that we want to write a script so that if we we input a number that is divisible by 3, we print fizz in the console. If a number is divisible by 5, we're going to print buzz in the console. And if a number is divisible by both 3 and 5, we're going to print FizzBuzz. So let's first by defining a couple numbers, okay? We're going to say number 1 equals 4, number 2 equals 6, number 3 equals 10, and number 4 equals 15. So if we look at it right off the bat, we know that this will just input the number, or return the number back, okay? Should print 4, because if it doesn't match any of these, we're just going to print out the number, okay? This one should print fizz. This one should print buzz because this number is divisible by 5. This number is divisible by 3. This one's divisible by 5. And this number is divisible by both 3 and 5. 15 divided by 3 is 5. 15 divided by 5 is 3. So this should print fizz buzz. So what we're going to do is say if my num mod 3 equals 0. So what this is checking is if some number called my num, which we haven't defined yet. So we're going to use this as our input variable. And let's first say my num equals number 1. Okay? So my num right now at this point equals 4. So if my num is mod 3, this modular is going to return the remainder of this division. So my num divided by 3. And if that remainder is 0, we're going to print fizz, because if the remainder is 0, that means it's divisible by 3. Elif my num is divisible by 5, right? My num mod 5 is 0. We're going to print buzz. Elif my num is divisible by 3 and my num is divisible by 5, and we forgot to write the 0, okay? And let's put these in parentheses just to be safe. print FizzBuzz. And then if it doesn't, print my num. Okay? So there's going to be a trick in here, and I want you to try to think about it and why this current setup won't work, but let's try it. Okay? So we know in this situation, my num equals number 1 is 4. So when we run this algorithm, we should see 4 in the console. Perfect. Okay? So now let's try number 2. So number 2 is 6. And based off of this, we should print fizz. Works so far. Let's try number 3. Buzz. Perfect. Okay, because 10 is divisible by 5, so we're going to get buzz. And now let's do number 4. So that only prints fizz. And this is the trick. Because if we were to go through this algorithm, we first check if my num modulo 3 is 0. Well, that's true for 15, right? We know that because it is divisible by 3. So it's not even able to check if it's divisible by both 3 and 5. So we can move this to the top. Let's just copy this whole thing. Call this if. This will be elif. And now it should work. Because first it's going to check if it's both divisible by 3 and 5. This is the least likely scenario, and it'll only be divisible by 3 and 5 to return FizzBuzz. And then if it's not divisible by both of them, it'll check if it's divisible by at least one of them. And then if it's not divisible by any of them, it should be my num. So if we were to run this, we get FizzBuzz over here. So let's try that again. This should be 4. This number 2, which equals 6, should still return fizz. This number 3, which is 10, should still return or print buzz. Perfect. And then number 4, which is 15, should return FizzBuzz. So this is a general application of if statements. This and right here is new because this is the syntax to check if two different things are correct. So let's move right along. The first loop we're going to talk about are while loops. And the idea is that you're going to do something while some condition is true. Okay, so it'll be while some condition is true. Then you're going to do something. Okay? Sorry. That's the general syntax. Okay, we're going to comment it out so it doesn't give any issues, but remember that. While some condition is true, we're going to do something. Okay? So let's say we want to print all the numbers and including 1 and 100. Okay, so 1, 2, 3, 4, 5. We don't want to go through and say print 1, print 2, and then you go all the way down until you say print 100, right? So there's an easy way to do this using while loops. We're going to first say output equals 1, and then while output is less than or equal to 100, you're going to print output, and then we'll increase it. Sorry about that. Equals output plus 1. Okay? So what this is going to do is first output is 1. It's going to print out 1, and then it's going to increase it by 1. So it'll be 2. Okay? And then once it hits the end of this, it's going to go back up to the top of the while loop. So it'll be output, so 1 plus 1 is 2, and then it's going to go back up and print 2. It's going to redefine output as 2 plus 1, which will be 3. And then it'll go back up, print out 3, and keep on doing that until this condition is false. Okay? And when that condition is false, that means output will be 101. It's going to stop. Okay? So if we're to run this, that's what it does, right? We go all the way to the top. It printed 1, right? Because output was 1, and then it keeps on doing it until it's no longer true, which means that it's greater than 100. So it'll stop printing. Okay? So that's the first introduction to loops, and the second one we'll go to is for loops. So let's go into for loops. A for loop is a loop that will continue doing the same thing for every object within some parameters. okay? And it's typically within, let's say, a list. So let's say we create some list equals to 1, 2, 3, 4, 5, okay? So all this is a list of 5 numbers, 1, 2, 3, 4, 5. Let's create a for loop that will print out every item in this list, okay? So we're going to say for or let's say item in some list colon. So this is how you will write it, and this is syntactically how it is. So for any item in some list, okay, and this could be, you know, just a list of anything. It could be words or strings, I should say. It could be integers, floats, whatever you want, but it's just for every item. So 1 is an item, 2 is an item, 3 in some list, okay? We're going to say print item, okay? We're going to print or run and look at it'll go 1, 2, 3, 4, 5, okay? So it's printing every item for item in some list, okay? So there's also a cool thing in Python for loops where you can actually get the counter as well. So we're going to say for kv in enumerate of some list. So k stands for key, v stands for value. That's typically just how I do it when I'm going through, you know, just some list, because it'll tell me what item and then the value of the item. We could say like counter and then value just to make it easier, okay? So we're going to say print counter value, okay? So what is going to happen? We're going to run it. It's going to print the counter, then the value right next to it, then it's going to go to the next one. So when we create this enumerate method, or when we write this enumerate method, it's going to create another variable we can call called counter, okay? And it's going to print it out starting at 0, so 0, 1, 2, 3, 4, and then it's going to go to value, or print the value, and the value is actually going to be the value in the list. Okay, so let's say we have a really long list and we don't want to have to go through every single item, right? We just know for whatever reason, we want to be able to print out the item in index 3. So all you would need to do is say print some list in the we'll say counter. Okay, let's start off with that. Okay, so now it's the same thing, but we're using the counter. So 0, 1, 2, 3, 4, if that makes sense. So if you can follow this, it's starting at 0, so counter's at 0. So the first time it goes through, it's going to print some list in the 0. Okay, then we're going to go to 1, and it's going to print some list in the 1. It's going to keep on going through. So let's say for some reason we wanted to, you know, just write something where we want to print it when the counter is 3, like we said earlier. If counter equals 3, then print some list in the counter. So if we run this, what's going to happen? It's just going to print it once in the third, or in the third index. Sorry about that. In the third index, which is 4. So 0, 1, 2, 3. All right. These are for loops. We kind of went a little bit more than just for loops. We use some logic within it, but just remember the syntax is typically for item in whatever you want to go through, and then you could just do whatever logic you want. Okay, thank you. Welcome to the functions section of this course, and we're going to learn how to create functions. Functions are reusable pieces of code that you can just repeatedly use throughout your project. It's really good and efficient to use them because you don't have to constantly retype code. So let's say you wanted to get an average of a certain list that you have. So you have a list 1, 2, 3. You can create code to save the average and do that every time you want the average, or you can create a function. And this using this def keyword to define a function. Then you send an argument, do some logic, and then return a value. Okay, so using this syntax, we can actually reuse this line of code to create or to find the average of a list of numbers. So if we were to run this in our console, we get 2, right? Because the average of 1, 2, and 3 is 2. All right, so let's get right into it. So let's talk about function terminology. We're going to hear a lot, so let's kind of look at one that's already set up and look at what we call different things. So First, we have our function definition, and this right here is our function definition. This is where we actually define the function and what it does. That's using this keyword def. In Python, there's other ways to do it in other programming languages, but def is how you do it in Python. Then we have the function name, which is my function. This could be named anything. It could be named my function 2. It could be named motorcycle. It could be named anything, right? And then we are sending in our arguments. Once again, the arguments can be named anything you want. It could be, you know, some arg, some other arg. It could really be anything you want. Then we have our code in here that says what we want the function to do. So since we started to change some stuff, let's copy this and this. So we're now referring to our function arguments, and now we're returning what we want our function to really do and return back to the program. Okay, so this is the function definition, and these are the arguments. This is the name. Okay, then over here, this is when we call the function. So this means that we are asking Python to actually execute the function. We change the name, so let's do that, and we can, since it's returning this argument here, arg3, we can save that value in my var. So when we call this function, it's actually returning a value that once it returns it, it's going to save it in my var. And then when we print my var, we go over here and it's 5, right? Because we're sending in 2 arguments. It's adding them and then returning them. All right, don't expect to understand everything right now. We're going to go more into it once we can actually see the terminology in action. So now let's go into the idea of the return in a function. So let's say we were to, define a function called my function, arg1, arg2, with a colon, right? Then we have print 3 and 4, or just arg1 and arg2, right? If we look at this, we're printing out these 2 arguments, but what happens, right? We just print it. Sometimes we want to create functions that return a value, and what that means is when we call this function, the function will actually give back a specific value, and we do that with the return keyword. So let's say we wanted to return arg1 plus, let's just do arg1, okay? When we call the function, my function 3, 4, and run it, we see 3 and 4. But what actually happened is the function returned a value of arg1. So if we were to print out, we see 3, 4, and then 3, right? Because when we print my function, it calls the function, executes all the lines of code. So first it's going to print this, which it does, and then it'll return a value of arg1. And our arg1, or argument 1, our first argument here is 3. So it'll print out whatever value is returned. So if we were to get rid of this and say return arg1 plus arg2, what do you think is going to happen? Well, it should get arg1 and arg2, so 3 and 4, and return arg1 plus arg2. So when we print it, we should get 7. And that's exactly what we do. So once you hit the return statement, the function stops and just returns whatever value it is. And the great thing is you can actually use it to define functions. So let's say we wanted to say is my sum equals my function of arg1. We'll say 3 actually, and 4. If we were to run it, nothing happens because we didn't print anything. But if we were to do print my sum now, we get 7, right? Because my sum equals my function 3, 4. You're sending these 2 arguments to the function, and then it's going to return arg1, 3 plus arg2, 4, which equals 7. So now right here, my sum equals 7, but we're not printing anything until we say print my sum, and we get it in the console. All right, so that's it for the return statements. So we had looked at this FizzBuzz algorithm in the past where if a number is divisible by 3 and 5, so the number modulo 3 is 0 and 5 is 0, it prints FizzBuzz. Otherwise, if it's just divisible by 3, it's going to print fizz, and if it's just divisible by 5, it's going to print buzz. Otherwise, it's going to print the number, and this should actually be my num. Okay? And this is great and all, but what if we want to make it a little bit more dynamic? Well, this would be a great way to turn this into a function. We want to keep this logic, but put it into a function, and we'll see why this is useful. So first, we're going to say def FizzBuzz, and you're going to put in an argument, okay? So we're going to say arg1, or you can name it whatever you want, okay? So let's say number 1, all right? Colon. We're going to take all this and indent it. So already, let's just put number actually. Already we've defined this function, but right now within the scope of this function, we want it to look at number, whatever is being sent to the function. So we're going to put number. All right, and let's copy and paste this. Okay. And what this is saying is we're going to give this function, FizzBuzz, a number, okay? And if that number that we send to the function is divisible by 3 and divisible by 5, it's going to print FizzBuzz. Otherwise, if it's just 3, it'll print fizz, 5, buzz. Otherwise, it's going to print the number. But let's turn this into a return, okay? If we were to return FizzBuzz and then return fizz, and then return buzz, and then return number, okay? So now it's not just going to print it. We can actually save that value if we wanted to use it for anything else, okay? So let's get rid of my num, and we've just turned FizzBuzz into a function. So we can say my result equals FizzBuzz of 15. If we print my result, we get FizzBuzz, okay? So let's say we wanted to see if two numbers have the same result, right? So we'll say my other result equals FizzBuzz of 30. So let's print my results and my other results, and both of them are FizzBuzz. So now we've taken this code and we can call it multiple times. So creating functions makes it a lot easier to organize your code because you can call these functions multiple times and it organizes all your code in one area, okay? So we can see in this situation now, if we were to just do my result equals my other result, it's true, right? Because they're both returning FizzBuzz, okay? So this is really good to know when you're creating code because you want to organize your code, and if you need to repeat yourself, you don't want to have to type all the code again. You just want to create one piece of code and then call that piece of code whenever you want to, and that's where functions come in handy, all right? Since we learned about functions, we're going to learn about recursion now. So recursion is a way that you can use functions that you can actually call the function within the definition of the function or within the function itself, okay? So what does that really mean? Let's first look at a non-recursive function example. Let's say we wanted to count down every number to 0. You input a number and it's going to go, let's say 10, it'll go 9, 8, 7, 6, 5, all the way down to 1. Okay, so we'll say count number while number is greater than or equal to 0, print the number, and then number equals number minus 1, okay? So if you look at this, we're going to get a number, and while it's greater than or equal to 0, it's going to print it, then it's going to decrease it. So if it's 10, okay, it's greater than or equal to 0, it'll print 10, then it's going to equal 9. It's going to keep on going through. So if we look on our console and we say count 10 and run it, we see 10 through 0, okay? But this function is really just doing one thing over and over again, and this is a great way to recursively call the function. So we could rewrite this function, let's get rid of all of it, and say print number. Okay, so if you put in 10, it's first going to print out 10. Then if number is not equal to 0, return count of number minus 1. So if we look what happens, let's say we put in 10, it's going to print out 10. That if number is not equal to 0, it's going to return the count of number minus 1. Okay? So what does that mean? Let's look at it. All right? So it goes from 10, 9, 8 all the way down to 0. Okay? So this is a way where you can actually call this function count. This is the same function as here. And all it's doing is once you call this, it's going to go back in here and recursively call the function. Okay? This could mean a lot, or be a lot, and we're actually going to look at an example. We're going to look at a Fibonacci sequence now. So a Fibonacci sequence is such that every number in the sequence is the sum of the two preceding numbers, as we can see in Wikipedia, right? So that means that f of n, so at any given point, equals the sum of f of n minus 1 plus f of n minus 2. So this would be like 3, and then 2, and 1. So this notation just shows which entry in the sequence it is. So f of 3, or f sub 3, would be the third number in the sequence, equals f sub n minus 1, so 3 minus 1, 2, and then f of 1, right? So that means that the third number in the sequence equals the value of the second number of the sequence plus the value of the first number in the sequence, okay? And we can look at this pretty easily in, the first few values, right? So let's pick one, 8. 8 equals 5 plus 3, okay? 21 equals 13 plus 8. And you can do this for every number, and it just keeps on going up, okay? So let's actually program this recursively in Python. We'll create our function called def Fibonacci, and it's going to put in some number. And our goal is we're going to input the number, so it's which number in the sequence it is, and is going to return the value, okay? So f sub 0 is 0, and f sub 1 is 1. So we know if we input 0, it's going to be 0. Otherwise, if it's 1, we're going to output 1. So let's start that. If number equals 0, we're going to return 0. Elif number equals 1, we're going to return 1. Okay? So this is where we're going to get into the recursive part. This, is easy because we already have these as givens. But now we have to look at it, okay, f sub n equals f sub n minus 1 plus f sub n minus 2. But we can look at this just as a function, right? This function of a number equals the same function of the number minus 1 plus the same function of the number minus 2. So we return that. And the way we type that in would be else return Fibonacci number minus 1 plus Fibonacci number minus 2. Okay? So now we're going to have a few tests. Fibonacci in the 0. Okay, we'll do 1, 2, 3, 4, 5. Okay, and we obviously could have done this in a for loop, and we will. So we'll run it, and we get 0, 1, 1, 2, 3, 5. Okay, so if we were to go back to Wikipedia and we look at the first two, 0, 1, 1, 2, 3, 5. That's perfect. Let's say we wanted to output or print the first 100 numbers of the sequence. We can do for I in range 0, 100, print Fibonacci of I. Okay, we run it. Oh, simple error. There you go. It's going to keep on going. and it takes longer and longer because of just the complexity of the algorithm. And when you learn about big O, you'll understand why it's taking longer and longer and longer. But if we wanted to stay here, we could figure it out. Let's give the computer a break and stop. But these are all the numbers in the sequence, okay? And we can see 8, 13, 21, 34, 85. We go over here, and it's the same one, okay? So that's it for this lecture, and you have an assignment next. All right, so welcome to the object-oriented programming section, or the object-oriented Python section to be more specific. We're going to talk about objects and what exactly they are, why they are used in programming throughout a bunch of different languages. And by the end, you'll be able to do something like this, where we have certain data types such as integers and lists and floats. But what if you wanted to create something of your own, where you wanted to store information in a structured, ordered way within one particular object? So right now, let's say we wanted to create an object where we can have different types of cats, right? Different instances of this cat object, and each one of these instances will have a name and an age. And let's say we wanted to perform methods on these objects. Like we wanted to, have it say meow when we called this method. Well, we could create a variable called myCat, and it'll create an instance of this object, class cat, with a certain name and an age, and then we could call different objects or different methods on it, such as meow. We run it, and it'll print out meow. If we could also do something like get mycat.name and print this out. And we'll see furry. All right, so this is what we'll learn to do: use objects, create a more organized way to store information in your program. All right. Let's jump into creating our first object, okay? So an object is defined by this class keyword in Python. So you type class, that is a keyword in Python, that's telling it, hey, I'm going to now define a function, okay? Or define a object or class. Sorry about that. So let's say we're going to do Jared Goff. So Jared Goff is a football player. He's the quarterback of the Los Angeles Rams, okay? So we can now define different attributes, okay? And an attribute is just something to describe the function, okay? So if we were to describe Jared Goff, he has a first name equals Jared. He has a last name, Goff. He has a position, so quarterback. Team, Los Angeles Rams. And a jersey number, 16. Okay? So this object is going to define or describe Jared Goff. Okay? And we run it, nothing's going to happen because we haven't done anything. All we've done is defined the object. But now that we have an object called Jared Goff, we can actually refer to different attributes. So let's say we're going to define a new object called person equals Jared Goff. Okay? So what this is doing is creating a new object instance, okay, that has all of these attributes, okay? So every time we say person equals Jared Goff, that means person now is going to save an instance of all this information, okay? What does that really mean? Let's get right into it. If we were to print person dot first name, okay, this dot is going to access one of the attributes. That's how you access the different attributes and properties in objects, okay? You use this dot. And then we'd say the name of the attribute, which is first name, okay? We could do last name, we could do position, we could do team. So if we're gonna run this, Jared dot, or person dot first name is Jared, okay? If we were to do person dot last name, okay, Goff, okay? So our person is now Jared Goff. Now we could create a bunch of different objects. So, we can do a class called Todd Gurley, who's another football player, and then go through all these same fields, or different same properties, but there's a much easier way to do that. Okay, where now when we define person, we can actually dynamically do that instead of having to rely on the same values for the attributes. So we're going to get into that next. As we said at the end of the last video, we want to find a more dynamic way to create objects or instances of objects, because we don't want to have to deal with a lot of different, class, whatever the person's name is, and then have to define, okay, we have a new person who's of, object Jared Goff, right? So let's create a more generalized way to do this. We're going to say class football player, okay? And now we're going to create a object method, okay? It's called def init, okay? So this is standard in Python. It's built in, so anytime you use this method init with these 2 underscores before and after, it's going to take initial values for the function, for the object instance. This doesn't really mean a whole lot, so let's actually start getting into it so we'll understand what that means. Okay, and let's get rid of all this for now, okay? So now we're going to put all of the values that we want to define. So in any object, you can reference itself using self, okay? So what this is doing is for any instance you define, you want to actually apply certain values to that instance. So let's say for self.firstName equals whatever we want it to equal, okay? What do we want it to equal? Well, this is a function, right? So if we were to just ignore this class football player part, just think of this as a function. Well, how would we send a value to the function? Well, we first have to send the value self, okay? That's in any object method. Then we're going to put in first name, okay? Then instead of it being any specific string, we can just say self.firstName is first name, okay? So now we can define Jared Goff equal to football player, and we're going to send in an argument, Jared, okay? So what's going to happen is anything you put in this parentheses is going to be sent to this initialization or this init method, okay? And it'll take the argument first name. It is implicit that self is being passed in, so you don't need to worry about passing self whenever you create a new instance of an object. And this is what we're doing. We're creating a new instance of football player called Jared Goff with different attributes. And the attribute for the first name is going to be Jared, okay? So if we were to run this, it's not going to do anything yet. But if we were to print Jared Goff dot first name, we get Jared, okay? So now let's add more, right? We have the last name, we have the team, we have position, and we have jersey number, okay? So let's say self.lastName equals last name, self.team equals team, self.position equals position, and self.jersey number equals jersey number. Okay, so now we're going to have to give multiple arguments to this object instance, right? Because right now we're just giving the first name. We're going to put in Golf as the last name. For team, let's do Los Angeles Rams. Position is going to be quarterback. And jersey number is going to be 16, okay? So now we can rerun the code and say Jared Goff dot position. What do you think we're going to get from here? It should be quarterback. And that's exactly what it is, okay? It's a little confusing. You have the self here. Go through this slow. Try changing different values, changing the names of different attributes, because it can be a lot at once just to understand what is this init method, what does self mean. There's a lot of resources to help explain what self is. And yeah, so notice though, we can change this to anything. We can say Todd Gurley. We can put Todd Gurley. But he's still on the Los Angeles Rams, except he's a running back. And his number's 30. Okay, now we don't have Jared Goff anymore. We have Todd Gurley. Dot position, and he's a running back, so that's what we'll get. So now you can easily reuse this code whenever you want to define a new football player. Okay, I know that's a lot. The self could be very confusing. Make sure you ask questions in the Q&A section if you come into any problems, and don't be afraid to Google anything that you may be wondering. Okay, thank you. So right now we're going to talk about object methods, and we already covered it a little bit using the built-in init method to initialize different instances of objects. But what if we wanted to make our own? So just to save some time, I created a class dog, so it's an object of class dog. We have our init function, right, where we send in self, which we always do, and then name, okay? And then when we create it, it'll be self.name equals name. When we create it, we do dog, name equals whatever you want the name to be. And if we were to print buddy.name, we should get buddy. All right, so this is what we've gotten so far, but let's say we wanted to add different things that this object can do, right? We're not just constrained by Python's built-in functions or methods, right? We can add our own. So let's say we wanted to make one bark. So we're going to say def bark, send in self. And let's say anytime we called this, we wanted to just output or print bark, okay? So let's say print bark, okay? So now let's get rid of this part and just say buddy.bark. What's going to happen? Well, in the console, we just see now bark, just what we printed out. So this is the simple way just to add a simple method to your object so you can actually call it on any instance of the object. So anytime you create a new object or a new instance of this dog object, you'll be able to call all of the methods that you define. Okay? Let's take it to a step further and send in our own argument. So let's say we wanted to have a custom way that you wanted them to say something, right? So you don't want them to just say bark. We'll say speak. And then we're going to say, words, okay? And then when we're going to send in the words that we want the dog to speak, okay? So what we would do then is words equals I am hungry. So what did we just do? In our definition of the object method, or the function, right? This is just a normal function, but it's within the scope of the object. We're sending in a new argument called words. And then we're printing out whatever we're sending it. So when we say buddy.bark, we call the function, and then we have to send in whatever words we wanted to say. So we're going to say, I am hungry. So when we run it, has no, oh, we forgot to change it to speak. I am hungry, right? Because we call the method speak, sent in words equals I am hungry, and we're going to print it out, okay? So this is how you would create a method. You could create whatever method you want. I would definitely suggest creating more to play around with it. Okay, thank you. Now that we understand objects a little bit more, let's look into an application of creating our own object and overloading a function. We've already done this by using Python's built-in init method, but we can do that with other functions such as addition, right? If we wanted to add two objects that we've created, we can actually overwrite the addition sign to do what we want it to do. So let's jump right in. We're going to start by creating an object of a complex number, okay? And each instance of this object will represent a complex number. What is a complex number? If you don't know, let's go to Wikipedia, and really it's a number that has two parts, a real part and an imaginary part. So we write it a plus bi, and a is just any real number, and b is a number multiplied by I, which is the square root of -1, okay? So the square root of -1 is assigned the value of I, so it's going to be a plus bi, okay? So any complex number has a real part and an imaginary part. That's really all you need to know for the context of this. And when you add two complex numbers together, you do the real part plus the real part and the imaginary part plus the imaginary part. Okay? So let's get right into it. We have our class complex number. Let's create our initialization class init self, and we're going to send in a real part and an imaginary part. Okay? We're going to say self.real equals real, self.imaginary equals imaginary. And there you go. We just created our initialization method for a complex number. So we can say C1 equals complex number, and we'll say it's going to be 1 plus 2i. Then we'll say print C1.real, C1.imaginary. Okay? So let's run it, and we should get 1 and 2, right? So this 1 is going to be our real part, so it's going to be the a in this a plus bi, and 2 is going to be the b, the imaginary part in the a plus bi, okay? So now, what if we wanted to take two complex numbers that we define? Let's say we define another one, C2 equals complex number of 2 and 5, okay? And we wanted to add those two numbers together, okay? These two complex numbers, which means we have to add 1 and 2, and then 2 and 5. Well, we use Python's built-in method, add, okay? Self and other. You can name this whatever you want, but this is going to be the other number you'll be adding, okay? So when we define C3 equals to C1 plus C2, C2 will be the other in this scenario, okay? So we're going to create new real equals self.real plus other.real. New imaginary equals self.imaginary plus other.imaginary. Now we're going to return a complex number instance, okay? So we're going to return an instance of our complex number where the real part is the new real, and let's be more explicit in our definition. Real and imaginary equals new imaginary, okay? So what we're doing is sending it, so C1 has a method called add, which when we do C1 plus C2, we're going to add self, so it's going to be C1.real plus other.real, which will be C2, and then self.imaginary plus other.imaginary. And this method will return, so when we do equals, it's going to save the value in the C3, so it's going to return a new complex number instance where the real part is new real, which is the adding the two real parts will be 1 and 2, and the two imaginary parts, which is 2 and 5. So if we now change this to C3, we should have an output of 3 and 7. And that's exactly what we have, okay? So I hope this makes sense to you. Try not to worry too much about understanding complex numbers as much as understanding why this works and how complex numbers are added in the context of this object, okay? So it could be any sort of thing, but you can override add and return any sort of value you want if you wanted to add two instances of your object, okay? Thank you.